Okay, so let's get started on this classwork. I've got a Jamboard here that I've set up. And the first thing we're going to do is take notes. Okay, so first thing we're going to do is take notes. So let's go ahead and you're going to write this down. Okay, today's classwork is worth 15 points because you have two little note sections that you have to submit and the 4 problems that we're going to do. So 15 points. Okay, so this is the first part of your notes. Go ahead and copy it down. Systems of linear equations. I get my pen. And I'm not going to write all this down, but you guys are. So start with systems of linear equations, and you put 631. This is the methods and meaning notes. But 6.3, this comes from 631 in your book. Systems of linear equations. Go ahead and write that down. A system of equations is a set of 2 or more linear equations that are given together, such as the example at the right. So go ahead and copy that down. I'm going to see if I can make this bigger while you're writing that. Wish there was a way that you could make this full screen, but there's not. But let's see, I'll just enlarge the picture a little bit and I'll lose this picture, but that's okay. Okay, that's a little better. So a system of equations is a set of 2 or more linear equations that are given together, comma, such as the example at the right. And we'll draw this at the right. One of the equations is y equals 2x. The second equation is y equals negative 3x plus 5. Those are different lines, right? So y equals 2x, since it's positive, it's going through 0, 0, and 1, 2. And then y equals negative 3x plus 5 is negative, so it's going down and it's going through 0, 5, and 1, 2. So you want to graph those 2 lines as well. Okay, so give you a second to copy this graph down right here. Okay, and let me just say, guys, in order to be considered present for the class, you have to be here for most of the class period. Okay, if you just check in for like 2 minutes or 7 minutes, you're getting marked absent. So a couple people have started to do that. So you will be marked absent, especially if you don't submit any classwork too. If you submit classwork, and then that's a different story. But if you just pop into Zooms for 2 minutes or 5 minutes or 7 minutes or even 10 minutes, if you don't do any classwork with it, you're marked absent, because that's not, our Zooms usually go like 45 minutes to an hour, about 45 minutes. So if you're not here for most of that period, you are getting marked absent. Okay. All right. So that's what a system of equations is. So let's go on to the next part. Get my pen back. To represent a system of equations graphically, you can simply graph each equation on the same set of axes. Okay, so we're writing this down. To represent a system of equations graphically, you can simply graph each equation on the same set of axes, like this. The lines may or may not have a point of intersection. The example at the right has a point of intersection, which is circled. So where these 2 lines intersect is at the point 1, 2, 1, 2, right? So that is the point of intersection of this system of equations. Okay, the point of intersection is considered the solution, right? So I guess you don't have to write this 3rd paragraph. You don't have to write all this down. I'll tell you what you can write. Yeah, you can write this part. This means that the point of intersection is a solution to both equations in the system. So you can write that down. So the point of intersection is a solution to both equations of the system. So the reason, 1, 2 is on this line, and it is on this line. It is on both lines. That is why it's considered the solution of the system. For example, the point of intersection of the 2 lines graphed above is 1, 2. This point of intersection makes both equations true, as shown at the right. Okay, so copy as much of that down as you can. I'll give you a couple more minutes, and then I'm going to move on to the next slide. When you're done, you can let me know in the chat you're done. That would be great, so I can know when to move on. Okay, guys, I'm going to move on. This is in your book. If you need to keep copying, this is in 631 in your book. So it's there, you know, if you didn't finish, that's fine. I'm going to clear these drawings and go to the next set of notes. We have one more set of notes here. This is from 641, methods and meaning notes, number of solutions of a system of equations. So that's the title. Let's write 641. Okay, get my pen back. So 641, number of solutions to a system of equations. So a system of equations can have three types of solutions. So that's what we're going to talk about right now. When two lines lie on the same flat surface called a plane, so this is an XY plane, this flat surface is an XY plane, they may intersect across each other once, an infinite number of times, or never. So they can cross once, an infinite number of times, or never. So those are your three possibilities. So go ahead and write that down. When two lines lie in the same flat surface called a plane, that's good to know because we don't talk about planes a lot. Planes are just any flat surface like a rectangular surface. You know, we make this the X and the Y axis. So this is the XY plane. Okay, where we graph things is called the XY plane. It's two-dimensional. Okay. So when two lines lie on the same flat surface called a plane, they may intersect, cross each other once, an infinite amount of times, or never. So it could be once, infinite amount, or 0 times. Okay, those are our three possibilities. Okay, so I'll read the next paragraph, a little short paragraph here. For example, if the two planes are parallel, if the two lines are parallel, then they never intersect. The system of two lines does not have a solution. Examine the graph of the two parallel lines at the right. Notice that they have the same slope, but different y-intercepts. That would be a good thing to write down. These two lines have the same slope, but different y-intercepts. And then we want to graph this. You don't necessarily have to write all this, but we do want to write parallel. If two lines, you could write two lines are parallel if they never intersect. Okay, two lines are parallel. So you have like one line, two line, they never intersect. That means they have the same slope and different y-intercepts. So we're going to write that down. Notice that they have the same slope, but different y-intercepts. Okay. When that happens, do they ever cross? Anybody want to unmute themselves? Do these lines ever intersect?
No.
No, they don't, right? So if they never intersect, they don't have a solution, right? So we say this system has no solution. Okay, no solution because they're parallel, right? We call this parallel. Hopefully you wrote that word down. Parallel means they never intersect. Never intersect. Okay, they have the same slope. They're going in the same exact direction, and that's why they'll never intersect. You have to slightly turn one of them so that they'll run into each other, right? All right, so the next one, the next situation is if the two lines lie exactly on top of each other, we say the two lines coincide. So that's good to write down. You don't have to necessarily write this whole paragraph, but that first sentence is good. If the two lines lie exactly on top of each other, we say the two lines coincide. So this is not an example of that. We would have to make another graph. If I made another graph, okay, and let's say, and we're going to do an example of this later. Let's say I have an equation of one line. It goes like this. But then I graph the other line, and the other line happens to go right on top of the red line that I just made. So where do they intersect? Many points, right? At every point on the line. So if they coincide, we say that they have an infinite number of solutions, or we say infinitely many. So I'm going to write that down. Infinitely many solutions if the two lines coincide. Okay, there are infinitely many solutions. Every point on the line is a solution. So every point on the line is a solution. Okay. And then lastly, we have this case here. The most common case for a system of equations is when the two lines intersect once. So that would be this situation right here, right? You have line number one, line number two, there's like line number one, line number two, and they intersect at one point, right? So this has one solution. Wherever they intersect is our XY solution. So this solution has one solution, namely XY is where they intersect. XY, where they intersect, is the solution. Okay, and hopefully you wrote down this system only has one solution. That's really important. One solution. Okay. The most common case for a system of equations is when two lines intersect once, like this, and you want to draw that picture, like put an arrow to it. This system has one solution. So usually we only have one solution, right? When the two lines intersect, that's usually what we have. But sometimes we're going to have no solutions when they're parallel like this. And sometimes we're going to have infinitely many solutions when the two lines actually end up being the same. And we're going to look at an example like this today. I don't think we have any where they're parallel today, but hopefully you might in your homework. Okay. So those are our notes. Might leave it up for just like another minute before I go on. This is in your book in 641. So if you still need to go back and copy it down, you can do that and just look in your book. All right, guys, I got to go back onto the next slide. So that's like 5 or 10 points of your notes today. So now we're going to do these problems together, starting with 45. All right, my pen back. Don't want to do yellow. You can't see that. So number 45, the tortoise and the hare. Hopefully you've heard this story when you were a kid, right? Who wins, the tortoise and the hare? All right, let's see. The tortoise always wins, right? Let's see. The tortoise and the hare are having a race. In this tale, the tortoise moves 50 feet per hour. So that's how fast the tortoise is going. While the hare, the bunny, moves 200 feet per hour. The tortoise takes 8 hours longer than the hare to finish. What was the distance of the race? Okay, so we want to know how long the race was. We don't know, you know, they raced some distance and we don't know what that distance is, right? So let T represent the unknown time in hours that it took the hare to complete the race. write an expression, not an equation, just an expression, so no equal sign, representing the time it took the tortoise to finish the race. Okay, let's write down how fast they're going. So first of all, the tortoise, I'm going to write tortoise, is going 50 feet per hour. Okay. The hare is going much faster, 5 times faster, right? He is going 250 feet per hour. Okay, 5 times faster. The tortoise takes 8 hours longer. Okay, and so he takes longer because he's going much slower, but it says to use T. Write an expression representing the time that took, let T represent the unknown time in hours that took the hare. So T is his time. T is the time for the hare. Oops, I read that wrong. The hare to finish the race. Okay, well, if T is the time for the hare to finish the race, and we know the tortoise took 8 hours longer, what would our expression be for the tortoise's time? If he took 8 hours longer than this time, how do you write that? T plus 8, right? Equals the tortoise's time. Tortoise's time, because T is the time of the hare. So T plus 8 is the tortoise's time. Okay, that's the expression. So that is the answer to part A. Part B says write 2 equations that represent the race, one for the hare and one for the tortoise. Okay, so we're going to use that formula that I talked about earlier in the chapter. Distance equals, who remembers it? It's very short. Distance equals what times what? You can unmute yourself or put it in the chat. No answers in the chat? Oh, one person. Yeah. Rate times time. Okay, rate times time. Distance equals rate times time. Okay, that is an equation you need to know, you guys. Distance equals rate times time. You can use it for anything that goes a certain amount of speed. So rate is your speed, right? Rate is the speed. That's what R is. And T, of course, is time. In hours or minutes, in this case, in hours, in feet per hour. Okay, if we don't know the distance of this race, that's what we're trying to figure out. What is the distance of the race? But we do know how fast they are going, and we kind of know their time. We have an expression for their time, but we don't really know their time. So write 2 equations that represent the race, one for the hare and one for the tortoise. So for the hare, the tortoise, if I start with that one, his distance, we don't know. His rate, he is going 50 feet per second. The time, his time is T plus 8. So we're going to put 50 times T plus 8. That is his equation. That is his distance equals rate times time equation. Okay, that is for the tortoise. For the hare, his equation, his distance equals rate times time equation is he's going 250 feet per second and his time is T. So his equation, the hare, is distance equals 250 T. Well, we want to figure out when the distance is the same, right? Because they traveled the same distance, like the hare went faster and then the tortoise is behind him, but eventually they finish. And you know the story, the hare like stops to rest or whatever, and then the tortoise passes him up. So, and the hare does all kinds of stuff, I don't know, and loses the race, but they end up finishing the same amount. So this distance is going to be the same because they travel the same amount of distance for the race. So we can use equal values and set these equal to each other. So if I do 50 times T plus 8 equals 250 T, that's our equal values method, and we just solve it. I'm going to undo the 50. Instead of multiplying it out, which we could do, it's actually faster to divide by 50. Divide by 50, and 50 goes into this side evenly, so that's nice. And we get T plus 8 equals 250 divided by 50 is 5, so 5t. And then I'm going to go ahead and minus t, because I want to bring the t's to the same side. There's 2 t's, so we have to bring them to the same side. And I get 8 equals 4t, 5t minus 1t is 4t. And then divide by 4 on both sides. So t equals 2 hours. So whose time is that? T equals 2 hours. Whose time is that? Please write that in the chat or say it out loud. Chat is good. Give you a second to write it in the chat. Is that the tortoise's time or the hare's time? Who is time T? Okay, I got 2 answers in the chat. I'll wait. Give me time to put some more in there. Oh, I got 2 different answers. 2 people disagree. We need a tiebreaker, guys. I need some more answers in the chat. T, is that the tortoise's time or the hare's time? Oh, okay. I got a 3rd answer. So she broke the tie. Okay, 2 people said the hare, one person said the tortoise. So yes, it is the hare's time, because we look right here, right? T is the time for the hare to finish. We defined it right there. So this is the hare's time. So what is the tortoise's time? How do we find the tortoise's time? What is the tortoise's time, guys? Put that in the chat too. One answer in the chat, yay. You do something with 8, yeah, you do something with 8. Do we add or multiply 8 to get the tortoise's time? Okay, we're just going to add 8 because right here it says t plus 8. So we're going to add 8 to the 2, because remember that he took 8 hours longer. So that the tortoise's time, which is t plus 8 is equal to 2 plus 8. So he took 10 hours. Okay, so the tortoise took 10 hours. But that is not what they ask us. They ask, what is the distance of the race? So how do we find the distance? We've got 2 equations right here, right? So to find the distance, we can use either of the 2 equations. I think I chose to use this one right here. So for part C, I'm going to write distance equals 50 times time, which is 2. We found t to be 2 plus 8, which is 10. So 50 times 10 is how many feet? $500 feet. And that makes sense because the hare raced for 2 hours and he was going 250 feet per hour. So that's 500 feet. And if the tortoise goes 10 hours at 50 feet per hour, he's also going to go 500 feet. Okay, so the distance of the race is 500 feet using distance equals rate times time and the equations that we came up with. Okay, so I would say this is a little bit more of a difficult problem. I'd give it like a B plus in difficulty, but this is something you need to be able to do. Okay, I'm going to erase this so we can go on to the next problem. Okay, next slide. Dragonflies and Fairies. Okay, let's read about, I think this girl is having a party. Yeah, it's like her birthday. Here we go. Phoebe was helping her mom buy party favors for her little sister's birthday party guests. There were 11 friends attending the party. So little girl has 11 friends. How exciting. Costume dragonfly wings cost $1, while fairy wings cost $2. Okay, so the boys are going to be the dragonflies and the girls are going to be the fairy wings in this case. You know, they could be whatever they want, but for this party, that's what it is. Phoebe's mom spent $18 on the gifts. How many sets of dragonfly wings and how many fairy wings did Phoebe's mom purchase? So we need to come up with 2 equations for this, okay? And you need to learn how to do this. Someone teach you how to do this. We've done some of them already, but here we go. So we know that she has how many friends coming to the party? 11, right? And some of them are girls and some of them are boys. So let's define our variables. Let's let X equal, or we could use B, but I'm just going to use X. So let X equal the number of boys, and let Y equal the number of girls. Okay, and you're usually, a lot of times you're going to have a problem like this where they tell you the total number. Okay, they tell you the total. When they tell you the total, that makes it super easy because you're going to come up with an X plus Y equation and it equals the total number. Okay, you're always going to have X plus Y equals the total. Well, our total is 11. So does it make sense that X plus Y equals 11? The number of boys plus the number of girls equals 11. We don't know what this is. We don't know if it's 5 plus 6 equals 11, or it could be 3 plus 8 equals 11, or it could be 1 plus 10. So there's a certain amount of combinations that we could have, right? But we know we're going to get something like this. So let me erase that stuff that I just did. So that's what we have to find, like, what is the combination? So that's where the second equation comes into play. All right, so we need to use, now we have like price, money. We have a money equation, right? The dragonfly wings cost how much? $1. So those are for the boys, so 1x. And then the other wings, the fairy wings, cost $2. So that's 2 plus 2y equals, and then how much do they spend total? Again, we're doing the total is always on the right. She spends $18 total, right? So now we have a system, right? This is called a system. We have a system of two equations, two unknowns. We have two unknowns, X and Y, and we have two equations to solve them. So we have to combine these equations to solve them. Okay, what should we do to these equations? What did we learn last class period that to do to solve the system? We have to do something to let's say the top equation right here. I'll give you a little hint, I'll do that. What should we do to the top equation to solve the system?
You have to multiply the entire equation.
By what number? Let's say I'm looking at the x's. This is an x and this is also an x, right? I need to add them together. So I want the x's to go away, but in order to do that, they won't go away right now. If I add them together, it'll be 2x down here, and I don't want 2x, I want 0x. So what do I need to multiply the top equation by to get rid of the 1x?
Would it be -1?
Yeah, we'd multiply by -1. Yes, it would be that. All right, we'd multiply by -1. Okay, so if I multiply the top equation by -1, I'm going to get -x minus y equals -11, right? Because I multiplied that by negative, negative, negative. They're all going to be negative. And the bottom equation, I'm going to leave alone, x plus 2y equals 18. And now we can add them together. And the x's are going to go away because they're opposites. We always try to get them to be opposites, right? Those are opposites, so they're going to cancel out. So 2y minus y, 2y minus 1y is 1y. And then 18 minus 11 is 7. So what does this mean? 7 whats attended the party? Look back at your statement. Good.
Amigos.
Yeah, that's the number of dragonfly or girls, right? So girls or dragonfly wings, that's the number of wings they bought. You're both right. So I'm just going to say 7 girls attended the party, but those are the dragonfly wings also. Okay, 7 girls attended the party. That's how many wings they bought, 7 dragonfly wings. So how many boys attended the party? Well, we know the total was 11, right? So x plus y equals 11. Somebody put that in the chat. Let me check. Good, four boys attended the party, because if I put 7 in here, you know, x plus 7 equals 11, x has to be 4. So 4 boys attended the party. And since this is a word problem, we want to write the answer as a full sentence. That's why I did that, right? I put 4 boys as a full sentence. 4 boys attended the party. Put a period at the end to make it a sentence. 7 girls attended the party. Full sentence, complete sentence for word problems. Okay. Okay, so that's how easy it can be to make a system from just 2 or 3 sentences here. Okay, you have to come up with the equation. You have to multiply by -1. Sometimes you have to multiply by other numbers, but we'll get to that in a second. All right, gonna go to the next one. Got to clear this out. Go to number 103. So we're on to a new section here, 6.3.3. How can a graph show the solution? Okay, so if we were to graph this, let's see what we're getting. So 6-103, get my pen back. 6-103. Tracy's team was given the following system by her teacher: 10x plus 4y equals -8, and 5x plus 2y equals 10. So hopefully you're writing this down. 10x plus 4y equals -8, 5x plus 2y equals 10. Use the elimination method to solve this. Okay, what happens when you use the elimination method to solve this? So if I use elimination method, let's see, I have 10y plus 4y equals -8. Okay, I need to eliminate these. So I don't know, let's say I want to eliminate the x's. What would I multiply the 5x by to get it to be the opposite of 10x? What would we multiply by, guys? I want 5x to be the opposite of 10x. Okay, got an answer in the chat. -2, okay? So far, we've only been multiplying by -1, but you can multiply by any number. It doesn't have to be just 1. Okay, we can multiply by 2, we can multiply by 3, we can multiply by -3, we can multiply by -5, we can multiply by -10. We can multiply by any number we want. It doesn't have to just be -1. Okay, and we would need to multiply this by -2 to make it a negative, oops, I put a 10x plus 2, I'm sorry, it's not going to be 2y. I need to change that, huh? And I need to change this y up here. This is supposed to be an x to match that one. So I have a positive 10x and a negative 10x. And then don't forget to multiply the rest by -2 like I did. -2 times positive 2y is -4y. So I need to erase this and put -4y. -4y equals, and then -2 times 10 is -20. All right, guys, look what happens when we try to add these two together. This is what happens. The x's cancel out and the y's cancel out. Well, if everything cancels out, what does that leave you with? It leaves you with 0. It means there's no x in the problem. There's no y in the problem. It's just 0, which is okay. 0 is a number. But then when we add -8 plus -20, we get -28. And is 0 equal to -28? Is that true? If I owe you $28, is it acceptable for you to take $0? Are you going to accept $0?
No.
Probably not. It'd be pretty nice if you did that, but this is a false. So what happens is you get a false statement, right? Like 0, you get a false equation. 0 equals -20. Well, 0 doesn't equal -28. And what happened was all the x's and y's went away. So we got a 0 on one side, but we didn't get 0 on the other side. So when this happens, what that means is it means that there is no solution. We're going to write no solution. Okay, this is our first problem where we get no solution because you can't solve this, right? So remember, we took notes. What does it mean when there's no solution? What's happening?
They're
The
parallel.
lines are, oh, I'm sorry, say again.
They're parallel lines.
Right, it means the lines are parallel. Okay, somebody's writing in the chat, so let me check there. Yeah, it means the lines are parallel. They're not intersecting. So these are two different lines because like when I multiply this, I get another 10x, another 4y. The 10, I can get both of these to be the same. If I multiply by +2, I can get this to be 10x and 4y, but then the right side will be different. So that tells me they have the same slope, but different y-intercept. So it means they're parallel and there's no solution. So this is what it looks like when you do these problems, when you get no solution. The x's and the y's are gonna cancel out, and then you're gonna get 0 on that side, but the other side, they're not gonna cancel out. Okay, what if these were the same? What if I would have got like instead of -8, this was +20, right? And I added these together and I would have got 0 equals 0. What does that mean when you get that? If you get that on your homework or a test or Delta Math or whatever, it means there are infinite solutions. Okay, it means it's the same line. It means, hey, they were actually the same problem. They're just in a different form, because like this ended up being +20, this ends up being -20, and all the x's, this is 10x, and both of these are 10y. So they're the exact same line. So that means, like, where do they cross? The two lines cross right on top of each other. So every point is a solution. So we say it has infinite solutions. You can use that symbol if you want to, but I like you to write it out. We like you to write it out. It has infinite solutions. That is when you get 0 equals 0. But if you get 0 equals another number, they don't cancel out, it's no solution. Okay, it means the lines are parallel. Okay, if you have not done so already, write both equations in y equals mx plus 20. Oh, we're going to skip that part because the next problem is going to do that. Okay, so we're good with A and B. I'm going to clear this out so we can do the very last problem. Okay, and go to the next slide, last slide here. Okay, the equations of two lines are given to the right here. A table of solutions for the first equation has been started for you. Okay, complete the tables for the given equations. Using only the tables, can you predict the solution to the system of equations? So let's go ahead and draw these equations, right? Like write them. Let me see if I can make it a little bigger so you can see it better. It's kind of nice. Let's see. So the equations are 10x minus 4y equals 8. So go ahead and write that at the top of your paper. 10x minus 4y equals 8. And then the table, the first xy table, they go by twos. So it's -6, -4, -2, 0, 2, 4. So they're going by twos. They're not going by ones, but they are going by the same number. So it should increase the same amount over here. Okay. So the first y coordinate is 17, then it goes up a certain amount to -12, then it goes up a certain amount again to -7. So if you figure out the pattern, how much it's going up each time, go ahead and fill in the last 3. Give me a second to draw all that and fill it in. After you finish that part, go ahead and copy down this table and that equation and see if you can get some values in there, and I'll go over them with you in a second. And take a second to stretch too. Stand up and stretch. I know I need to stretch. My neck starts hurting when I look at the same position. So I actually made a standing desk. I put 2 boxes next to each other. I put my laptop on the left box and my writing tablet on the right box. And I'm standing up right now, so I don't have to keep sitting. All right, guys, what did you get for What is this going up by each time for this one?
5.
Good, it's going up by 5, right? So if I add -7 and I add 5 to that, what is my next number going to be?
-2.
-2, and then I take -2 and add 5 to that. What's that going to give us for our next number?
+3.
Good, +3, and then I add 5 to +3 is going to give us
8.
good, 8. Good. So those are the numbers. Hopefully you came up with that. Now when you plug in numbers into here, I like to plug in 0 first because that's always the easiest one. If I plug in 0 into here, I'm going to get 5/2 times 0 minus 2. What's that going to give me? It's going to give me -2, which is, notice, is the same as this. Okay, now 2 is an easy number to plug into here because it's 5/2. So if I do 5/2 times 2 minus 2, these 2's are going to cancel and just be 1's. So I get 5 times 1, which is 5 minus 2. So that's going to give me 3. So far, this is going up by 5, just like the last one. So let's see if we get 8 for this one. Let's do 5/2 times 4 minus 2. Well, 2 goes into the 4 2 times. 5 times 2 is 10. 10 minus 2 is 8. So basically, it's the same pattern. So is it safe to assume that this is going to go back 5 and go -7, and go back 5 and be -12, and go back 5 and be -17? Okay. Well, if that's the case, what do we know about these two lines? Even though they have different equations, this one and this one, what do we know about the two lines, guys? They're actually the same line, right? Because they have the same points. So I'm going to type that in here. See if I can type that in here. Let me do it. Let me try it again. The two lines are the same line because all the points are the same. So if they're the same line, how many solutions does this have? There's 3 possibilities, right? There's 3 possibilities for our solutions.
Infinite.
Good. You can have 0 solutions, 1 solution, or infinite amount, right? If they're the same line, then yeah, it means they're the same. They're going to cross everywhere. So yeah, infinite. So this has infinite. Here we say infinitely many solutions. So we're going to write that down. Okay, and that's what you would write on a test or your homework. It has infinitely many solutions, and there is work to show for this. Okay, just because an answer is infinitely many or no solutions doesn't mean you show work. You always have work. Okay, so this is our work right here. We show that, oh, you know, all the points are the same, so it has infinitely many solutions. Okay, when two lines lie on top of each other, we say that two lines coincide. So part C, let's write the lines coincide. Some good vocabulary here because that's an English word that you use. So when two things coincide, they end up being the same. Okay, solve the system algebraically. What kind of algebraic solution do you get for the systems when they coincide? Okay, let me answer that. Somebody wrote something in the chat. Okay, you're good. You're good, Reese. So if we solve this algebraically, there's 2 ways we can do it. I need to erase some of this because I need room. So I gotta erase this. Kind of want to erase that. Maybe I'll work over here on the right. Do my work over here. Okay. How I did it earlier is I kind of showed that these equations are the same, but Remember earlier I said, hey, if we add these together, you're going to get 0 equals 0. Remember that? So if we did add them together, we get 0 equals 0, but it's hard to do that because this isn't in this format. It's not in standard form. This is in slope-intercept form. So what I did is I solved this, which we usually don't do it this way, but for this problem, it's kind of like the easiest way to do it. So let me erase this. Now this is in my way. So if I solve, give me my pen back. Okay, 10x minus 4y equals 8. If I solve this for y, right? This is what we did at the beginning of the chapter, is I want to solve this for y. So we have to bring the x's to the other side. So this is good review because this is going to be on your test too. I think this was on your Delta Math, maybe. If not, it will be next week. Okay, so negative 4y, your test is going to be on Delta Math. So you totally want to do the Delta Math assignments, guys, because it's going to help you prepare for the test. The more Delta Math you do, the more better you're going to be prepared. It's going to, you're going to take the test and you'll be like, oh, this is easy. I did it when I did the homework. All right. Then we're going to divide by -4 to get the y by itself. And 10/4 reduces down to 5/2, 5/2 x. And then 8/4, 8 divided by -4 is -2. So you can see when I change this equation to y-intercept form, look what I get. I get the exact same equation. So even though they look different, right? Like this equation looks different from that, it's actually the same equation, right? When you put it into slope-intercept form, it becomes the same equation. So since they're the same, we'll put the equations are the same. I have a little abbreviation for equations. The equations are the same. So since they're the same, it means, hey, the lines coincide. It means one line, and then the second line is actually the same line. So we have infinitely many solutions. Okay. All right, guys. So let's look at what your homework is. I gotta clear all this away. And let me go ahead and stop this recording here.